So we start here in the lab manual with just the static spirometer type of readings. And that's the first part here, starting on page 55, actually page 56 with the first measurements. You have the ability to calculate tidal volume directly with the wet spirometer. The minute respiratory volume is another term that's used for the total ventilation rate. Right? Minute respiratory volume, total ventilation rate is what we're looking at here. So this would take into account your tidal volume and your breathing rate, right? We multiply those together to get your minute respiratory volume. So we'll talk about how that's measured here. And then the expiratory reserve volume, the extra amount of air that you can exhale after a normal exhalation, that can be done using a wet spirometer, given that it's exhalation. And vital capacity. We can actually get a vital capacity measurement with the spirometer as well, given that vital capacity is a measurement of how much you can forcibly exhale after a forced inhalation. So you take the biggest breath you can, and then you exhale as much as you can, right? And for the machine, we would be measuring how much you can exhale, right, for that measurement. Then we can calculate inspiratory capacity. We can calculate inspiratory reserve volume. We can calculate other types of capacities as well, such as the total lung capacity. We will use information about the individual's characteristics, for instance, to estimate their residual capacity as well. And once we have all of those measurements, we, I believe at that point, have made either all the measurements we could with the spirometer, and or estimated all of the measurements that we could based on the spirometry readings that we get. So the first thing you're asked to do is calculate your ventilation rate. And this is something you can do at home. It's usually easier to ask someone to help you. So if you have someone in the house that can watch you breathe, I know it sounds creepy, but to watch you breathe for 30 seconds or a minute and just count how many breaths you take while resting, that would be great, because it would be probably more accurate than you trying to count how many breaths that you're taking as you're taking them. But here, all you want to do is count the number of breaths, right, in 1 minute. So you know breaths per minute, you want your breathing rate. Breaths per minute. And you could do something simple like how many breaths you take in 30 seconds, and then just double that to get a quicker measurement. That is fine. Then where we actually start in the lab manual is with the tidal volume measurement. And since you don't have a spirometer handy at home to take this measurement, we're asking you to use this value for tidal volume. So 450 milliliters is going to be the volume that is used. Okay. And then from there, we go on to calculate certain capacities and volumes here. We also, since we can't use the machine to measure ERV, I mean, we can, but you don't have one to do so. Your ERV is given here as 1,000 milliliters. So we're going to just keep those numbers in mind as we look at some examples of these measurements and calculations here. So based on that information alone, right, we can work through all of the other capacity and volume measurements that we need. And then the third step is simply to complete those practice spirometry problems at the very end of this, this section on page 58. The next few slides here have some information about the calculation that is the total ventilation rate. Remember I said in the lab manual, it's called the minute ventilation volume, but it's the same thing where we're multiplying the tidal volume, the normal amount of air exhaled per breath, by the breathing rate. Okay. And we don't need to worry about calculating alveolar ventilation here. We don't know your specific dead space volume. We could estimate it. On average, it's about 150 milliliters, right? This is the anatomical dead space where air is trapped in the conducting zone. That's attributed then to, or attributable to your residual volume, the air that is stuck in your lung space that you can't exhale because it's in the conducting zone. And then we'll come back to this, calculating vital capacity. These measurements are in the lab manual. And so you would choose either males or females here. You'd have to know your height and your age in order to do this calculation. But this is what we would use to get the normal value for an individual of your height and age and your sex. Right? So we calculate the normal value. But this vital capacity measurement can be done with the spirometer. That's the amount of air that you forcibly exhale after a forced inhalation. That will give you the vital capacity. And then what we would do is take that number and compare it to normal to see what % of normal you are, right? Are you at 100% or are you less than 100%, for instance, or greater than 100%? It could be better than average. Here, since we're not giving you an actual value to use, you're just going to assume whatever you calculate here for normal is you. And so when you get that value, you're going to use it for yourself and you're going to use it for the normal value, which will mean that you're going to be at 100%. Right? We'll just make it that way for that calculation that you do there. And so I'll come back to that point when we take a look at that. Then we have information about estimating the residual volume. This is pretty quick and easy to do. It's simply based on your age and your sex here. You choose which of these, and this is cubic centimeters, which is milliliters. So 1 cc equals 1 milliliter. We do that quick conversion there. And that would be your expected residual volume. And that's what we would use for that RV measurement, right? And so that was some of the information that comes right from the lab manual as well. Just some extra stuff here on the slides. So let's go to this section. And I'll blow this up so we can see this. This is on page 56. And so what I'm going to do here is I'm going to use the measurements that I took using the spirometer in the lab room. So these are actually my own measurements. They're not great measurements, but they're measurements nonetheless. And I'll just remind you at each step along the way what value you would be using potentially, given that you're going to use the numbers that are there on the lab tutorial. And of course, there's going to be some deviation here, like I said, in terms of what values you get in the end for your volumes, given that you are different sexes, ages, heights, what have you. So those values will differ. So with the spirometer, in order to calculate the average tidal volume, what we would do generally is get an average here by taking 3 breaths, 3 expirations into the spirometer. And so typically you practice breathing normally for a minute or 2. And then you take 1 breath in, right? And then you exhale into the spirometer. Move away, 1 breath in, exhale into the spirometer. Move away, inhale, and then back to the spirometer to exhale. So like I said, it's a little unnatural in terms of the movements you undergo, the inhale, the exhale, and making sure that the exhale is always into the spirometer. And on top of that, with each one of these measurements, you have to make sure that you plug your nose, right? Why is that? When you exhale, right, into a tube, why do you want to plug your nose? To get an accurate reading.
Like all the air is just like coming out of your mouth instead of like your nose, so you don't lose air.
Exactly, right. You get an underestimate of your lung volume because you would have air that's not going into the tube, right? Coming out of your lungs through your nostrils. And so, so that's something we have to keep in mind as well. Makes it, once again, a little more unnatural here. Right? The fact that you're plugging your nose and you're trying to have a normal exhalation during the process. And so the idea here is we would exhale 3 times in a row into the spirometer hose. And then we would take that total reading that we get after those 3 exhalations, looking at the dial. And so I did this, for instance, and I got 1 liter total across 3 readings. And I just want an average for 1 breath, right? 1 tidal volume. So I'm just dividing 1 by 3, right? That would be 1/3. I would say 333 milliliters per breath. That's my tidal volume based on the reading here in my average. The number you were given, right? Your value for TV was the 450 milliliters per breath. So that's going to be your starting point here. That's what you use whenever you need to utilize the tidal volume in these later calculations. Okay. Any questions about that so far? All right. Well, the next calculation involves taking your tidal volume here. The tidal volume, I'm going to use my 333. You're using your 450, and we're multiplying that. Let me use my units here. We're multiplying that by the ventilation rate, the breathing rate. And so, you know, this was in the tutorial that you want to determine your breathing rate, how many breaths you take per minute. And you either do that yourself or have somebody at home help you count the number of breaths you take per minute. And of course, this should be normal resting breathing rate here. And what I got for my ventilation rate was 20 breaths per minute. Okay. So this is going to give us our MRV, otherwise known as our total ventilation rate, our TVR. Breaths cancel out. So we're talking about how much air we're moving in and out of the lungs per minute. Here I got 6,660 milliliters per minute. Right? So that would be my total ventilation rate or minute respiratory volume. So you count your breaths, you multiply that by your 450, and you're going to get a different value here than I did. Next up, we use the spirometer once again to get the expiratory reserve volume. This is the amount of air that can be forcibly exhaled after a normal expiration or exhalation. And so what this would involve is an individual having the tube, the hose, set up and ready to go, and they would be breathing normally, right, in and out. And after a normal exhalation, they then turn to the tube, right, plug their nose and breathe out as much as they can, right, after that normal exhalation into the machine, into the spirometer. And it can be as slow as possible, right? That's actually preferable here because we want to get an accurate amount of the volume, and we don't want any air trapping during this measurement versus the other measurement where we're taking time into account. So normal exhalation to the machine, exhale the excess on top of that. That gives you your ERV reading. So when I did this, the amount of air that I could exhale after my normal exhalation was 0.9 liters, so just under a liter. So that is equivalent to what? 900 milliliters, right? The number that you're using, right, was given to you. Your value is going to be the 1,000 milliliters for your ERV. Okay. So that's the ERV that you would write here, and the ERV you would use in later calculations, the 1,000 milliliters. Vital capacity, right? If we were in the lab, we'd have two different ways of getting normal values. We could use the equations that were here to get the normal vital capacity. We also have various types of charts that we have up in the room that can be used in the same way, looking at your sex, your height, your age, and determining what would be the normal vital capacity for those characteristics. And here, let's see. I was able to use the spirometer. So here's my reading on the spirometer. And to get this reading for vital capacity, we would take a forcible inhalation. So inhale as much as possible, as slowly as possible. And then from there, exhale into the machine as much as possible, as slowly as possible while plugging your nose. Okay, that gives you your vital capacity, the amount you can forcibly exhale after a maximum inhalation, or the maximum amount you can exhale after maximum inhalation. So what I got here was 2,000 milliliters, right, for the vital capacity. And then I use this equation here to calculate what would be my what would be normal for my age and my sex and my height, right? And when I calculated normal using these equations here, calculate normal, right? I had gotten 3 liters for vital capacity. So that would be equivalent to what? 3,000 milliliters. So let's do that, 1,000 milliliters, right? So I have normal, I have my reading. Keep in mind what you're going to be doing here, if you haven't done so already, is that you're just going to use the equation, right? Use the equation that's going to give you what would be the normal value, and you're going to pretend that that is your own as well. And that makes you 100% of normal, right? Quick note here about age. Now, it makes sense that we might take into account sex here, because generally there is a difference in terms of lung volumes for males and females. Height makes sense as well due to body size. There's going to be a difference in lung capacity. Age is interesting to think about. We can ask, well, why do you consider age here? And the reason is because the vital capacity tends to decrease with age, right? That kind of makes sense. Vital capacity tends to decrease with age. And this is in part because the diaphragm weakens as you age. And so upon inhalation, right, the volume won't open up as much. And so you'll have less in, you'll have less out as you age. And you also have, progressive loss of elastic tissue as you age. That just naturally happens. And so you're going to see, increased resistance upon exhalation. You lose some of that elastic recoil, not obviously to the extent that we would see for an individual with an obstructive disorder like emphysema, but it does become progressively more difficult to have a normal passive exhalation without some air trapping. Right. And so I'm going to take my numbers here and I'm going to use them on the next page here. I'm going to I have calculated my VC using the equation, and I have my VC from the spirometer. That was 2,000 milliliters. The equation gave me 3,000, right? Keep in mind that you're using your calculation here, right? Your calculation. And the same calculation here. Don't worry about the VC from the chart posted in the room. You weren't in the room where a chart was posted, so you don't need to answer that question. And then all we do to get the percent normal here, VC percentage, is divide what was our reading by normal, multiply that by 100. So here I would have 2,000 divided by 3,000, multiply that by 100%, right? That's going to give me here 67% of normal. Since you're using the exact same answer for your calculation, it's going to be 100%, right? That's what you should get there. Okay, and so this number belongs here, minus 67%, and your value you should calculate to be 100%. So at this point, that's all we can do with the spirometer. We can take those 3 measurements directly with the spirometer. What we do from here on out, we have to incorporate various types of equations in order to determine the inspiratory volumes and capacities, and use normal values for certain volumes that we can't measure directly. Right. So let's take a look at inspiratory capacity here. To calculate inspiratory capacity IC, we can take into account the vital capacity, right, and the ERV. Because if we think about vital capacity, what we would do is we would add the tidal volume to the inspiratory reserve volume to the expiratory reserve volume. And this right here is the inspiratory capacity, the tidal volume plus the inspiratory reserve volume. So we take IC and in the ERV, and if we want to solve for IC, we subtract the ERV from the vital capacity from the VC. And we have this value and we have this value, right? That will allow us to calculate IC. So my values here were 2,000. That's what I got from the spirometer from my vital capacity. Yours is whatever you calculated there with the equation, taking into account your sex and your age and your height. And then we're going to subtract from this the ERV. Yours was 1,000. Mine was the 900 milliliters. And here is where we begin to see different values. That's the value that I get for IC, and you'll get something different. 1,100 milliliters. And now we can use that inspiratory capacity to help us determine the inspiratory reserve volume. Because the IC, as I showed above here, it's a helicopter going over, sorry about that. You might be able to hear that. The tidal volume plus the inspiratory reserve volume gives us the inspiratory capacity. So we rearrange this now so we solve for IRV, because now we have our tidal volume and we have now an inspiratory capacity. So my inspiratory reserve volume would be the inspiratory capacity, 1,100 milliliters. Yours will be different. And your tidal volume is also different. It was given to you at 450 milliliters, so that's what you would use here. And I had gotten the 333 milliliters, so I'm going to use that here. So my IRV is then going to be 767 milliliters. Okay. Next up, to determine residual volume, we are going to estimate that based on your characteristics, sex, and age. And there's some information here. For instance, we can't measure this directly because you can't voluntarily exhale this, this air that is trapped in the dead space, right? The only way we can get a measurement of that volume is to squeeze it out of you after you're dead, right? We can get an accurate measurement then of just how much air is in that dead space, if you will. So since we're not going to be doing that, we can use indirect measurements. One way we can measure this indirectly is to do it experimentally. And this is kind of costly because you need a whole body chamber in order to get this measurement in this way. And it's called pulmonary plasmography. It takes into account, you know, your circulation. It takes into account your weight and your respiratory volume, and all of these other things are accounted for. And it is meant to more accurately estimate your individual residual volume. We're just going to use this table that gives us a normal value, an average value, based on your sex and your age. And so you go to this table, you find your sex, you find your age group, right? And so I would use this value here. And keep in mind, cc, 1 cc equals 1 milliliter. Let me just do that quick conversion, right? So use whatever you get from that table as your residual volume. So I'm going to be using 1310 milliliters. Okay. And now that we have that estimate, we can determine the FRC, the functional residual capacity. You were given your ERV, remember that's 1,000, and you just estimated your RV from this table here. You add those two together, you get your FRC. I'm going to use the value that I had calculated for ERV here in this measurement at 900 milliliters. And what we get from the table, I'm going to use the 1310 milliliters. And so for me, this is my FRC. So you find out what yours is there. And that leaves us with one more calculation we can do, and that would be the total lung capacity, the TLC, right? And there's different ways we can think of the total lung capacity, right? So all of the volumes added together, the IRV plus the TV plus the ERV plus the residual volume, the RV. And some of those we can then simplify, for instance, right, such that we have something like the IC, inspiratory capacity, the IRV plus the TV, and we just add that to the FRC, right? That would be the ERV plus the RV. And so since we have those two measurements already, we can use that to determine total lung capacity. Or we could do it another way, right? We could use our vital capacity, which is IRV, right, TV plus ERV. And what's left is the residual volume, the RV. So vital capacity plus the RV, we have both those measurements, so we can determine TLC that way as well. You should try it for both of them, and you should get the same numbers in the end. You should get the same volumes for your total lung capacity, and then you know you did the calculations correctly. So I'm going to calculate it both ways here. I'm going to start with FRC plus the IC. And for me, the FRC from above, this number here, 210 milliliters, I add that to the IC that I calculated earlier. My IC was 1100, whoops. gone too far. 1100 milliliters. That gives me 3310 milliliters for a total lung capacity. If I did it this way, RV plus the VC, what would I get? Well, the RV from the table is 1310. And the VC that I calculated for myself, so I'm going to use my own value here, my 2000. You're going to use what you get from your equation. That's also going to give me 1310. Okay, so the numbers here, oops, 3310. There we go. Those numbers here match. And that's what you want to see when you use both of those equations. These were the practice problems I was referring to earlier, where you're given certain capacity values and volume values. This RR refers to the respiration rate, the breathing rate, so 16 breaths per minute, for example. And then you're asked to use that information to help you calculate different volumes or capacities. So that will give you some practice with using the different equations and rearranging them so that you can use them in this way. So I want you to know how to calculate, right, certain volumes or capacities if you're given data like this. Very similar to what we were doing with the renal clearance calculations, but now applied to respiration.